Following on from the previous video, we would start out with the Maclaurin series, and then we would apply this transformation. By us applying this transformation, we would shift everything across by A, giving us this. So we shift everything across by A. So once we get to this stage, we would demand that the first derivative of this to match up with the first derivative of this. We would demand the second derivative of this to match up with the second derivative of this. We would demand the third derivative of this to match up with the third derivative of this. We would demand the fourth to match up with the fourth, and so on. By us making these demands, eventually this red line here will map on top of the blue line centered at A. So we would start out with a general series. So we shift everything across by A. So we would start out with a general series, and then we would demand that the first derivative match up with the first derivative. We would demand the second derivative to match up with the second derivative. By us making these demands, eventually this would map on top of this. So we would differentiate this, and then differentiate this, and then we got to this stage in the previous video. So the third derivative will be this. Now if you differentiate it again, this is a constant. It doesn't contain x. So when you differentiate this, it disappears. If you differentiate this, it will just leave you with this constant. And then there are more terms over here. If you keep on differentiating it, it will then give you this. Now if you differentiate it again and again and again and again, you will get to this stage here for the nth time. So this will be your constant. So if you go back to the third derivative, if you look at this constant here, this is a constant. So in a way that matches up with this, and then you've got a constant, and then you've got a constant, and then you've got the bubble here, and then the next one you will have something, and then it will be x minus a squared. You would have something, and then x minus a squared. The point is that if you keep on differentiate it four times, that will then take you to here, and then if you keep on differentiating it, that will then take you to here. You might have to press pause and think about it. So if you keep on differentiating it, you will get to here. So now going back to here, we are trying to search for these coefficients in such a way that this thing here, this red line here, will map on top of this blue line. So looking, remember, we would demand that at x equals a, because we shifted across by a. Remember, we shifted everything across by a. Now we want to demand that the first derivative of the red line to match up with the first derivative of the blue line centered at x equals a. So that's our first demand. So our first demand is that our first demand is for this to match up with this. So at x equals a, if you put a into here, so that would be you putting a into here. A minus a, that will be 0. So this thing here will disappear at x equals a. If you put a into here, so that's you putting a into here. So a minus a, this will be 0. 0 squared will be 0. Times this, it will be 0. The point here is that at x equals a, this will disappear. This will disappear. So your coefficient a1 is really f prime. So this coefficient here, a1, is f prime, or evaluated at a. So the second derivative would be evaluated at a. Remember, you would demand that the second derivative of this to match up with the second derivative of this. So at x equals a, you would put this a into here. So you would put the a into this x here. So this would disappear. This whole thing here would disappear. Put a into here. So a, take away a, that would be 0. This whole thing here disappears. So by you demanding the second derivative to match up with the second derivative here, at x equals a, this will disappear, this will disappear. So your coefficient a2, would be f double prime, or evaluated at a, divided by 2. So that would give you your second derivative. That would then give you a second coefficient. remember you can obtain f double prime evaluated at a by using this. And then for this one here, for this one here, you would demand the original function of this to match up with the original function of this evaluated at x equals a. So to figure out the first coefficient, we would demand that the original function to match up with the original function at x equals a. So at x equals a, if you put it into here, that would mean you putting a into here, a into here, a into here. So all these terms disappear. So your coefficient a0, your coefficient a sub 0 would be f of a, f evaluated at a. So the point here is that if you keep on making these demands, you can eventually figure out all these coefficients. You can eventually figure out all those coefficients. So if you if you want to figure out the coefficient an, it would be you differentiating it n times evaluated at a divided by n factorial. If you look at this, if you follow this, it will then lead you to this. It will then lead you to this. So your general your n function would look something like this. Okay, and then you can summarize it to this. Sorry, the last bit I've lost track. So you just got to follow it through for yourself. Okay.